So hello students, today I am going to explain the concept of number based conversion. So as we know, what are numbers? Number is a method of representing in a different form. So now what are this number based conversion? Number based conversion means it is a method of converting one number form to another number form. So let us see how to convert to different forms. There is a possibility of converting a number from binary to decimal, decimal to binary, and similarly binary to octal, binary to hexadecimal, similarly decimal to hexadecimal or decimal to octal. In different way we can convert. So here we are going to learn in detail regarding this. So let us see the first concept, that is converting the number, binary number, to decimal. Converting the binary to decimal. So we know all this number system, it follow the positional weightage principle. Let us see how to convert the binary number to its decimal form. So let's take one simple example, binary number. If I consider the binary number as 101. Now how to convert this number to its decimal? So what we have to do is we have to multiply by its positional weight. So you know what is the positional weight of the particular number. So in general we can write the position of nth digit of a number, so that's equal to nth digit into base to the power n minus 1. So this is a method of this method we have to use to solve this. So let us see how to solve this number. So this is what I said, we have to convert our binary number 101 to decimal, that is let's see, so these are the number 1 with the base value, this is 2 with the position is here, third position minus 1 plus 0 into the position that is second position minus 1 plus similarly one more digit, that is unit digit, that is 1 into 2 to the power first position minus 1. So when we multiply this, we are going to get 2 to the power 3 minus 1, that is 2 here. Once again 2 to the power 1, that is 1 into 2 to the power 1 minus 1, it is 0. So we know 2 to the power 0 means 1. So when we multiply with, we have to multiply with 1. Next 0 into 2 to the power 1, 2 to the power 1 means it is 2 into 0, that is 0 itself, and similarly 2 to the power 2, that's equal to 4 into 1, that is 4. So we know 1 into 1 is equal to how much? That is 1 itself. So when we add this number, so that is 4 plus 0 plus 1, so it will give you the result as 5. So this is what our equivalent decimal number. Okay, for binary 101 is represented in decimal as 5. So let's take one more example for the same format, converting the binary to decimal with a fractional value. If I take an example of 10.01, this is what my example. This example here I want to convert this number to decimal. So now how to convert this number to decimal? So let us see here. Already I said you have to multiply with the positional weight. So this is all the method. This is in the fourth position minus 1 plus 0 into 2 to the power 3 minus 1 plus 1 into 2 to the power 2 minus 1, then plus 0 into 2 to the power 1 minus 1. Next, after the decimal point, the value will be the negative number. So let us see here, that is here it will be 0 into 2 to the power minus 1 plus next one is 1 into 2 to the power minus 2. So here we are going to get the result as 2 to the power 3, 2 to the power 3 means it is 8. 8 into 1, that is 8, plus here if we multiply with any number 0, so we get a result as 0. The next 2 to the power 2 minus 1, that is 1, that is 2. 2 into 1, that is 2, plus here that is 0. If we multiply any digit with 0, so it will be 0. Next, after the decimal point, so let us see how to convert, how to get a power of negative numbers. So we know 2 to the power minus 1 is equivalent to 1 by 2 to the power 1. So that is 1 by 2 to the power 1 means that is half. We know half is equal to how much? That is 0.50. So 0 into 2 to the power minus 1, so that will be what? 0.50 into what? 0 plus, similarly we know 2 to the power 2, 2 to the power 2 to the power minus 2, so that is equivalent to 1 by 2 to the power 2. 1 by 2 to the power 2, so that is equal to 4. So 1 by 4 is equal to how much? That is 0.125. Sorry, 0.25. 0.25. So that is 1 into 0.25. So let us see, we have to add this number, 8 plus 2, that is 10. 0.5 into 0, that is 0. 1 into 0.5, that is 0.25 itself. So finally we have to add this number, so finally you are going to get the result in this form, that is 10.25. So this is what equivalent decimal number. So this is what the method, this is how the method of converting binary to decimal. So let's move for one more concept, the reverse of this. That is decimal to binary. Converting decimal number to its binary form. Now how to convert decimal number to its binary form? So let's take one simple example. Convert the decimal number 42 to its binary. So now how to convert this decimal number to binary? So now what we have to do is we have to divide the number with the base value of the binary. What's the base value of the binary? That is 2. So let's see how to divide this number. So here with this was the number, that is 42. Already I said we have to divide it by 2. So let's see, we'll divide it, and whatever the remainder we get, that we have to write it separately. So let's divide it. 2 2s are 4. 2 1s are 2, there is no remainder, so I will write it as 0. Similarly, once again divide by 2. 2 how many times? 2 10 times 20, so 1 is the remainder. Similarly divide by 2, it's possible to divide, so 2 5 times 10, so remainder is 0. Similarly 2 times 4, so 1 is the remainder. 2 1 times 2, so the 0 is the remainder. Now how to represent the answer? I said we have to represent in a binary. So this is what our most significant bit, and this is what our least significant bit. So this is what the method of representing our answer. So answer is, if you convert 42 to binary, the answer will be 1 0 1 0 1 0 1 0 1 0 1 0. So this is in a binary form. So this is representing binary number. Let us see, if for example if the decimal number contains any fractional value, how to convert that fractional value to its binary. For example, if I consider the example of 0.75, this is in a decimal. Now you have to convert this into binary. Now how to convert this decimal number if it is a fractional value? So what we have to do is we have to multiply with the base value of the binary. So let us see how to convert this. So 0.75 into 2, we have to multiply by 2. So 2 5s are 10, similarly 2 7s are 14, plus 1, that is 15. So now after before the decimal there is one remainder, so this we have to consider it as a remainder, so that will write here, and then once again we have to multiply by 2. So once again what we are going to get, 2 into 0, 0, 2 into 5, 10. So 1 is a remainder. So now we have to consider this 1 as a remainder. Now if I multiply by 2, I am going to get the result as 0 itself. So now I am going to stop the multiplication. So now this is what our result. So result must be represented in this way. So 0.75, that is equivalent to 0.11. So this is what our binary value for the given decimal number.